Good afternoon. I'm Joshua Fair, and today I'll be introducing the key static topics of shear and bending. Let's go. So, an overview. What is shear and what is bending? Well, shear and bending are used in daily life. First off, shear. Shear is the application of two objects or one object being applied a perpendicular force in different directions. An example of that is the scissors. As you cut the two objects in different sizes, the knives go down in different directions and they cut the objects. For bending, well, it's just a force being applied to bend an object. In this example, the person right there is bending a ruler. So, both of these concepts, shear and bending, are crucial parts of physics and statics, and they involve various topics such as forces, moments, and equilibrium. In this lesson, I'll be going over shear and bending in more specificity, as well as these topics in more detail. So, what is shear? Here we go. Basics. Shear, like discussed, is a perpendicular force applied to an object. As you can see in the image, two forces are applying to the object, up and down, represented by V. V represents shear. When discussing shear, there's a key concept that relates to shear as well, which is a shear moment or a moment in general. A moment is distance times the applied force. So, an example. A funky graph you see on the left there is a shear moment graph, and it'll be used later on in a key example that we'll be discussing. A shear moment graph is it allows students or a person to see how shear changes across various points on a rigid body, again, which will be discussed later. So, what is bending? Bending is the tendency to want to bend in response to a moment, and the force will eventually cause the object to bend as the force is applied. Now, key thing about bending is that it also relates to a bending moment. And as discussed, a moment is an applied force times a distance. Similar to before, that funky little graph on the left is a bending moment graph. And the bending moment is when the beam is staying rigid and the force is being applied. And you're able to see how bending changes across the various points on the rigid body. Both of these concepts will apply to an example that we will be discussing now. So, rigid body equilibrium. A rigid body equilibrium is the most popular problem where shear bending is applied in statics. Key concepts like that I discussed earlier that we applied to this problem include equilibrium, a state of when objects are equal or equal to zero, external reactions, where structural parts such as joints are supported by force, and moments, like discussed, distance times the applied force. So, how would you even begin to solve a rigid body problem? The first step will be to calculate the shear and bending for a rigid body, and it requires 3 steps. First, compute the external reactions on the object, either in the x or y direction. Second, divide the object into different cuts or sections in order to find the forces and moments at each section to keep it in equilibrium. Third, repeat this for each part that you decide to cut, where the object has a change in shape or type. And fourth, plot the result on the shear and bending graphs as discussed before. So here's the example. To go for this example, as you can see, it's a rigid body. We're going to be going for the steps. First, geometry. Second, external reactions. Third, cut object. And fourth, plot the results. So as you can see on the right, I first break down the example into geometry. There's a triangle, so you find the geometry of a triangle. From there, you find the external reactions. You sum it with the moments, and from there you get your B and Y. AY is where the pin is, and BY is on the opposite end. This is the external reactions. These are supporting structures, and the joints are supporting the objects. From there, you cut the objects. The most logical cuts or sections are the one with the triangle and the section next to it, which has a rectangle. Once you cut these sections up, you would then continue to use moments and forces to get your shear and bending for each section as discussed before. In summary, shear and bending forces are used to solve rigid body equilibriums. When you follow these steps, you were able to solve equilibrium, and you can take the equations to graph them on a bending and shear graph as well. This concept is crucial in engineering and in statics. Thank you for watching.